is equal to 1110 divided by summation, which is what? 40. So my assuming is 61. So my mean is going to be equal to my assuming, which was given the question as 61, plus summation f this what? Minus 110 minus 110 divided by 40. So that will be equal to 61. You see that plus times minus. Let me just put inside bracket because of the minus sign. So plus times minus is what? Minus. I'll now do 40. 110 divided by 40. That's 2.75. So I'm going to do 61 minus 2.75. So 61 minus 2.75. That is equal to what? 58.52, which is the same as what we had before. 58.52. So you see that with both methods, you still have the same what? Answer. So this one is the assuming method. This one is the long method. And the last one is the coding method. So I'll look at this. The coding method, the formula you are going to use is this. Okay. Mean is equal to assuming plus summation fu all over summation f divided by what? Times c. C is the class width I talked about before. Class width CW. And I said that the class width is what? 5. In case you have forgotten, this is what I did. I said you are going to count from the list number is of 48, 49, 50, 51, 52. That's 5 numbers. So that gives you the class width. If you still do it for this one, 53, 54, 55, 56, 57. That also gives you what? The class width. That's 5. That is where that 5 comes in from. Here, the assuming that they used here for this is 60, not 61. So here you choose the assuming by yourself. So you choose the assuming to be 60. Now let's get the code. U is the code. How did they get that code? Now let me tell you how they got this code U. In a very simple way. For the first part, x is 50. U is equal to x minus assuming divided by the class width. So I want to tell you how they got this U. Now let's see. For the first part, the mean is what? 50. So I have 50 minus the assuming they choose here is 60. And it's preferable to even have choose assuming to be what? 60. Now let me tell you why they choose assuming to be 60. This is 50, 55, 60, 65, something. 60 is at the middle of these 5 numbers. So it is preferable to choose a number that is close to the middle, which is 60. Here you see that they also use 61, which is also close to the middle. And the good thing is that if at all we use 60, they choose an assuming of 60 here, we will still arrive at the same answer. No matter what assuming we choose, we will get the same answer. Or at least we estimate the same answer. So I have 50 minus the assuming, which is 60 that they choose, divided by the class width. The class width is what? 5. So 50 minus 60 is what? Minus 10. Minus 10 divided by 5. That is equal to what? Minus 2. So that is how they got you. For the next one, 55. I'll just do for these two. So I have 55 minus the assuming, which is 60, divided by the class width, that's 5. So I'm going to have 55 minus 60 is minus 5. Divide that by 5. That is equal to minus 1. So you see how we got minus 1 here. So that is how we do that. Now let's see, 60 minus 60 is 0. 60 divided by 5 is what? 0. That's what got 0 here. 65 minus 60 is what? 5. 5 divided by 5 is what? 1. 70 minus 60 is what? 10. 10 divided by 5 is what? 2. Now how do we now get FU? FU means F times U. So 8 times minus 2 is minus 16. 12 times minus 1 is minus 12. 10 times 0 is 0. 6 times 1 is 6. 4 times 2 is 8. So when you add all of this together, I'll start from below again because of the minus at the top. So when I add all of this together, 8 plus 6 plus 0 minus 12 minus 16 is equal to what? Minus 14. So that's how we have minus 14 here. So let's go back and apply that formula now. So we already know what summation FU is. Summation FU is equal to this. This by summation FU is equal to that. So we know what it is, minus 14. So let's apply to this formula. Okay, this is my formula here. So my mean is equal to my assuming. The assuming that we choose here is 60 plus into bracket minus 14 was our summation FU divided by 40 total F summation F total number of items there 40 times the class width, which is what? 5. So I'll just go to work this out. This is going to give us, so see, plus times minus is minus. So I have my mean is equal to 60 minus, so I'll do 14 divided by 40, then I'll multiply by this 5 times 5 times 5. That's equal to 1.75. So I have 1.75. So I have minus 1.75. So that will give us, so this is 60, 58. So if we subtract that, that will give you exactly this value here, 58.25, which is the same as all the answer that we have gotten. Now I am sure that this means something, this arithmetic means something. Should be very easy for you to do now. Now let's go to geometric mean. I'm even tired. Geometric mean. Now in geometric mean, instead of adding all the numbers together, you multiply them by together and take the nth root, or you use logarithm to do it. So I'll take another example to show you what this means. Okay, the intake of baby milk food observed in 15 children in one day are provided below: 101, 114, 109, 135, 122. Okay, there are many. 180, 184, 196, 185, 217, 198, 148, 233, 227, 336, 257. Calculate the geometric mean. So this is how you calculate the geometric mean. Just take the square root. Write a square root. I'll do it in two ways, the two methods. Take a square root and count the number of times. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That is the 15th root. You need a calculator to be able to solve this. So you are going to multiply every together. 101 times 114 times 109 times 135 times 122 times 184 times. Okay, I think the best way we should do this is just multiply it out with the calculator and put the values inside it, because it's going to be very long. So let me erase this, please. Let me just bring out my calculator and multiply everything together and put inside the square root and into the 15th root, so that I don't waste too much of my time. But that's what you should do. Just multiply all of this. So my calculator is out. So I'm going to have okay, 101 times 114 times 109 times 135 times 122 times 184 times 196 times 185 times 217 times 198 times 148 times 233 times 336 times 253. So that gives us, so I'll just round this up to 1.74. I'll round this one up to 1.74 times 10 raised to the power minus 31. So I'm going to write 1.74 times 10 to the power 34. 1.74 times 10 raised to the power, I think it's 36, not 34, times 10 raised to the power 31 times 10 raised to the power 31. So you can work that out from your calculator. Then on your calculator, let me convert my calculator to scientific calculator so that I can take the 15th root. So I'm going to take the 15th root. How do you take the 15th root? On your calculator, you have 15 root on this. You have root on this. Okay, this is my calculator. I don't have root, but this is what I'm going to do. I'm going to open a bracket and write 1.74 exponential. Okay, this is my exponential 31. And I'll close the bracket. So when I close the bracket, I'm going to write raised to power. I'll open the bracket 1 divided by 15. Then I'll close the bracket. So this is the cube root of that value there. So this will give us 120.9777, 120.977. Okay. Maybe I omitted some of the value because of my calculator cannot give me the actual value, but that is what you should do. Just multiply all the values together and take the 15th root of the value. Then we can also use logarithm method. Now to use logarithm method, I'll bring out my calculator and you are going to do this. We are going to take the logarithm of all this number and divide it by 15. Take the logarithm of number, add them together. And let me get my calculator. So I'm going to start with this. Okay, because I rounded my values up, I think that's why. So I'm going to take log. Oh, my scientific calculator is not the normal calculator. It's not the normal calculators. It's not the normal calculator, so it's giving me some little problem. But what you should do is, okay, I have 1 101, logarithm of 101 plus logarithm of 114 plus logarithm of 109 log plus logarithm of 135 plus the logarithm of 122 plus the logarithm of 184 log plus 196 log plus 185 log plus 217 log plus 198 log plus 148 log plus 233 log plus 227 log plus 336 log plus 253 log. So you are going to say equal to, then divide it by 15. Divide it by 15. The total number 15. That will give us 2.2394. So look at this. The 15 comes from the addition of all the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here you are going to press shift. So you now have to find the anti-log. So that's 2.23. Let me write 2.24. Let me press 2.24. Let me just approximate that to 2.24. So I have 2.24. Then you now take the anti-log of this number. You take the anti-log of this number. Let's go back to the calculator. Just press shift. The anti-log here. Oh, okay. It's natural logging. There's no anti-log here. There's no anti-log here. Okay. So you have to press that from the calculator. But we can just take the anti-log of this by writing 10 raised to power 24 0.24. Let me write that. The anti-log is actually 10 raised to power 2 times 10 raised to power 0.24. You can find the anti-log like this if you don't have a calculator with you that can give you an anti-log, because this is the same as 2 plus 0.24. So 10 raised to power 2 is 100 times, so just go to your calculator and press 10 raised to power 24. 10 raised to power, where's my raised to power? Okay. Oh, this is actually anti-log here. I didn't even see. 10 raised to power 24, 0.24. That's equal to this. Then multiply that by 100. So that's going to give us 251. So what I got is 251 point something. Okay, I think there is an error in their calculation here, because the values they got there deviates. So you can use this to get your anti-log anyway. 10, let me see, 2.24. So you can do this. You can just take this and write 2, okay, 2.24. This calculator is not the normal calculator, so we have to press the number first. 2.24 this. So it's 173. Okay, it's 173. That's the correct answer. 173.78. 173.7. That's the correct answer. So that's the anti-log. So 173.28. So this answer is correct here. So when you take the anti-log, that gives you 173.78. So these are the two methods that you can use to calculate the geometric what? Mean. Okay, so let's go to the harmonic mean. For harmonic mean, take the reciprocal of the number, then divide it by the number of terms. What this means is this. Let's see. For this, we have to find numerical values of 1, 2, 3. We calculate it and compare the AM means arithmetic mean, GM means geometric mean, HM means what? Harmonic what? Mean. So let's just take the arithmetic mean. These are not group data. Since they are not group, I just add them together. 1 plus 2 plus 3 plus 4 plus 5. That gives you 15. The number of terms are what? 1, 2, 3, 4, 5. That's why you have what? 5. Divided by 5. That gives you 3.0. Now to calculate the geometric mean, multiply these numbers together and take the number of terms is 5. So take the fifth root. So I have 1 times 2 is 2. 2 times 3, 6. 6 times 4, 24. 24 times 5 is 120. So we are going to take the fifth root of 120. On my calculator, it's quite often that I don't have roots. But let's see. So if you don't have root, what you do is just write 120 raised to power. So put a bracket 1 divided by 5. That's what it means. So that will give us 2.60. So that gives us 2.605, which is correct. Maybe because the other data was too long, that's why I could not get the correct answer. Then if you want to use logarithm again, you can also use logarithm if you don't want to use this method. How do you use logarithm? Take the logarithm of all this number 1. So you are going to write 1, the logarithm of 1, plus the logarithm of 2, plus 2 log, plus 3 log, plus 4 log, plus 5 log. So this will give us 2.075. Then I'll divide that by the total number 1, 2, 3, 4, 5. So that gives us 0.41. So you are going to take the anti-logarithm of 0.41. Just write this. The exponential of 0.41. And that gives us 2.605, which is the same as what we got before. So it's the same as 2.605. So if you take the, that will give us 2.60517. So we just upgrade 2.605, which is the same result as what we got in the first part. So for the, okay, that's for the geometric mean. Then for the harmonic mean, we are going to do this. The number of terms is 5. 1, 2, 3, 4, 5. So harmonic mean is, the number of terms is 5 divided by 1 over 2, 1 over these 2, no, 1 over 1, 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 4 plus 1 over 5. And this is going to be the harmonic mean HM. Let me just write this way. Is equal to 5 all over 1 divided by 1 is 1 plus 1 divided by 2 is 0.5 plus 1 divided by 3 is 0.33 plus 1 divided by 4 is 0.25 plus 1 divided by 5 is 0.5. So add all of this together. So I have 1 plus 0.5 plus 0.33 plus 0.25 plus 0.5. So that's equal to 2.5. So I'm going to have is equal to 5 divided by 2.58. So I divide that now. 5 divided by 2.58. That is equal to 1.93 continuous. 93798 and so on and so forth. So they say you should compare them. So if you compare them, which of them is the greatest? The arithmetic mean was 3. 3 is higher, followed by the geometric mean was 2.65, and this one was 1.93. Okay, I'm tired. Let's go to the mode. The mode is the middlemost number, is the highest frequency in the distribution. What it means is that if you have a group of number, the one that occurs mostly, the one that is highest, is the mode. So let's look at this number. 52475 3. See that 5 appeared twice. So the mode is 5, and this is called unimodal because it has only one mode. This is called unimodal because it has only one word, mode. Now let's look at this. We have 2, 6, 3, 4, 3, 2, 5. 2 appeared 2 times. 3 also appeared 3 times, which are the most. So we have 2 modes, which are what? 2 and 3. And this is called what? Bimodal. Now look at this. 4, 7, 2, 1, 3. All these numbers, they occurred only once. So none of this number, there is no mode in any of this number. Now for a group data, like the one we did in the first part, if you want to get the mode, you use the formula. Let me just simplify this formula for you so that it becomes easier for you. The mode is equal to L. L is the lower class boundary of the modal class plus FM. FM is the cumulative frequency of the modal class. Then FA is the cumulative frequency, is the frequency above the modal class. Then I'll write this as FM minus FA. Okay, let me rewrite this. Let me just write it in another format that will be simple, simple for you to use. When we are solving the example of this, you get it. So I use D1 plus, okay, D1, imagine I'm watching football, all over D1 plus D2 times C, the class width. Now, let me explain what D1 is. D1 is equal to FM minus FA. See, I want to see, I'm simplifying it now. Then D2 is equal to FM plus FB plus FB, yes. Then because I'm using what I have here to do it, FB, yes. So when you add minus FB, sorry, minus FB, minus FB. So when you add this and this together, this is what's going to give you this. Okay, let's see if we can take an example on this. Okay, the median. There's no example on that, the median. The median is at n plus 1 over 210. What this means is that, let's look at this. To find the median of this number, find the median of the following set of data. This is an ungroup data. So to find the median, this is what I'm going to do. You have to rearrange the numbers from smallest to the highest. So the smallest number is 2. Then I have 3. I have 3 again. Then I have 4. Then 6. 1, 2, 3, 4, 5. We have 5 numbers. 1, 2, 3, 4, 5. So the median is at, median will be at n. It's the number of them. 1, 2, 3, 4. That's 5. Plus 1 divided by 2. 5 divided by 1 is, 5 plus 1 is what? 6. Divided by 2 is equal to 3. So the median is what? 3. So the median is 3. Now, let's go to the next one. So I'll arrange again. For this one, I'll arrange it. So the median is at the third term, rather. So this is position, not that the median is 3, it's at the 13th, at the third term. So let's count. 1, 2, 3. This is the third term. So the median is 3, which is correct. The median is what? Equal to what? 3. So let's look at this again. Let's arrange this. I have 2. I have 3. I have another 3 again. I have 4. I have 5. And I have 8. The total numbers are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the median will be at n plus 1. That's 6 plus 1 divided by 2. That is equal to 7 divided by 2. That is equal to 3.5 position. The 3.5 position. So we'll go to this place. This is 1, 2, 3, 4. So 3.5 is between 3 and 4. So we'll just take them together. Add 3 plus 4 divided by 2. So that's equal to 7 divided by 2, which is equal to 3.5. So to calculate the median of a group data, we use median L is equal to L. L is the lower class boundary of the median class plus N is the number of frequency divided by 2 minus the cumulative frequency before the median class divided by the frequency of what? The median class. So let me put M here, Fm, meaning the frequency times the class interval. Let me see if I can find examples on this. Okay, using the examples given in the data given the example above, consider histogram. I don't know the examples they are talking about. But let me see. I'm tired. Okay, let me stop this video here. Some other time I can do another one. Oh God.